Another way that we can model games is using a sequential move game, where one player moves first and then the second player moves right after him or her. And we can easily transform any simultaneous move game into a sequential move game and vice versa. But when we do so, sometimes the Nash equilibrium can change. So we do want to be very careful to see whether or not we'll end up with the same solutions when we transform these games. So let's go ahead and see how these sequential move games are actually going to go ahead and be formed. So the sequential move game, sequential move games. And these are not as common as the simultaneous move games, but they do provide a lot of important information regarding mutual interdependence and human behavior. So with sequential move games, we're going to use game trees in order to analyze this type of game. With sequential move games, we're going to use game trees for analysis. So use game trees for analysis. Analysis. And it's also called extensive form analysis because it really does look like some type of tree. It's more extensive compared to the simultaneous move game. Let's go ahead and transform our Prisoner's Dilemma with Christopher Maloney and Mariska Hargitay into a sequential move game. And with this, we need to go ahead and say which player is going to move first. Here, let's go ahead and say that Mariska is going to move first. So she is player number 1 in this instance. So Mariska. And Mariska, she has 2 strategies. So what 2 strategies can she choose from? She can either say, I don't confess, do not confess, or she can actually confess. So she has 2 strategies. So these are the branches of the tree that we're introducing right here. And then once she makes her decision, whose turn is it? It's going to be player number 2, and that's where Chris comes in. So Christopher Maloney here, Christopher Maloney here. So we open this up to his 2 strategies as well. And Chris has the same 2 strategies. He can do not confess or confess. So do not confess right here. And then confess. And then this one's do not confess, do not confess. And then this one's going to be confess. So here, as you can see, it almost looks like a tree, but this is exactly how the sequential move game works, where player number 1 moves first, and then the player right after him or her is going to move second. And we're going to attach the payoffs that we saw previously. So if Mariska does not confess and Chris does not confess, we're moving up along this top branch right here. Both of them get 1 year in prison. So 1 year, 1 year. And sometimes it's actually easier to introduce some type of dollar element just to make this a little bit easier for analysis. So let's go ahead and just say that, hey, $75 and $75 right here. So they're going to be sort of attached to these number of years in prison. Next, we go ahead. What happens if Mariska does not confess, but Chris decides to confess? That's where Mariska gets 3 years in prison, 3 years, but Chris gets off scot-free. He gets 0 years in prison. And once again, just attaching some type of dollar amount, we can say this is going to be $25 and this is going to be $100. Same thing along the lines, right on the bottom half of this tree, it's just going to be symmetric with one another. So Mariska confesses, Chris does not confess, so therefore Mariska gets 0 years in prison, 0 years, but Chris gets 3 years, and this is where we get the 125 right here. And then finally, if both of them decide to confess, then both of them get 2 years in prison. So 2 years, and $50 each. $50 each. So remember, we want the lower number of years in prison, or if we just want to go ahead and use the dollar amounts, we want the higher amount of dollars. We want the most amount of money. But as we can see right here, this is going to exactly match up with the payoffs and outcomes that we had under the simultaneous move game. However, we now have players moving first and players moving second. So is there some type of first mover advantage, or is there some type of second mover advantage? Remember, the first numbers that come up right here are going to be for player number 1, and the second numbers are going to be for player number 2. So we read from the tree left to right. The first player that we hit is player number 1. So $75, $25, $100, $50, or the 1 year, 3 years, 0 years, 2 years goes to Mariska. And then as we move along the tree, the next player that we hit, that's player number 2, so Chris. So the 75, 1 year, 100, 0 years, 25, 3 years, $50, or 2 years that's attached to Chris. So don't confuse the elements. However, in order for us to solve out the Nash equilibrium in this game, we need to read the table from right to left. We don't read it from left to right. Left to right is just to help us identify who's player number 1 and who's player number 2, as well as these payoffs right here. And in order for us to solve for the Nash equilibrium, we read the table from right to left. And this is going to be a methodology known as backwards induction. Backwards induction. So we use the best response technique for simultaneous move games. For sequential move games, we use backwards induction. So how does this work? We start off at the top half of this table and we keep reading from right to left until we hit the very first player. And the first player in this instance is Chris, who is player number 2. So if Chris is player number 2, but he, as we read from right to left, what decision would be the best thing for Chris to do if we ever reach this situation right here? Should he not confess or should he confess? If he does not confess, he gets $75 or 1 year in prison. If he confesses, he gets $100 or 0 years in prison. So which one's going to be the best thing for Chris to do? He wants to get 0 years in prison. He wants this $100. So therefore, Chris knows that if his decision ever comes up this path, he is always going to want to confess. So you draw a little bit of an arrow that goes down this way, and you say, hey, we sort of prune the branch or sort of just trim it. And Chris knows not to do not confess if he ever reaches this point. He knows that he wants to confess because he'll get 0 years in prison or $100 versus 1 year in prison or $75. Then we follow the same methodology with the bottom half of the table. If we ever reach the bottom half of the table, Chris has the same strategies. Does he want to confess or does he not want to confess? Once again, we need to compare his payoffs. Does he want 3 years in prison and $25 or does he want 2 years in prison or $50? Once again, he only wants 2 years in prison or he wants $50, so therefore he knows for sure that he's going to confess if we ever reach that part of the tree, and he's going to prune that. So pruning just tells us that, hey, do not go down that path, follow the arrows. So far, hopefully this makes sense so far, but then we keep on reading from right to left and we hit the next player. And the next player is going to be Mariska, player number 1. So she knows exactly by reading off the table, because there's perfect information, what Chris is going to do. She knows that, hey, if I go up this part of the tree, he's going to confess. If I go down to the bottom half of the tree, I know he's going to confess as well. So what would be the best thing for Mariska to do in this scenario? Do not confess or confess. If she chooses do not confess, she knows for sure Chris is going to confess, and that means she would get 3 years in prison or $25. However, if she chooses confess, she knows Chris will confess, will get on the bottom half of this tree, and she'll get 2 years in prison and $50. So what is the best thing for Mariska to do here? The best thing for her to do is to go ahead and say, hey, I want to go ahead and confess as well. So here we get $50 compared to the $25. So I forgot to mark this for Chris right here, but this is exactly where Chris chooses confess as well. So here, Mariska says, I'm never going to go down that path right here. I'm never going to choose do not confess. I am going to confess. And what do we see happening here? We notice that Mariska chooses confess. Chris chooses confess. We have 2 underlines right here. So therefore, this is going to be seen as our Nash equilibrium. So Nash equilibrium. And we notice that this is actually the same strategies for both of these players and the same payoffs as it was under the simultaneous move game. So in some instances, the sequential move game gives us the same answer, the same Nash equilibrium as the simultaneous move game. But that's not always going to be the case, so you do want to be aware about that when you transform these games from one to the other. Here, Mariska chooses confess, Chris chooses confess, they both get 2 years in prison, and the prisoner's dilemma is still actually going to hold. Once again, we use backwards induction in order to figure out what the Nash equilibrium is. You read the table, you read the tree from right to left, and then you follow down the pathway. You prune off the branches where each player is not going to go down, and use arrows to show exactly what pathway they're going to be led to. We'll work with another example for extra practice in our next video of the sequential move game.